Alright, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still inside our optimization module. Let's have a look at what we went over tonight. Now, last night, if you can remember, we did go over some mock code of how we would implement a hill climbing function. This is it here. We actually did add some more pieces of code to it. I guess we're doing it piece by piece and not all as a whole. But yeah, that's what we went over tonight, and then we actually did some more writing and note taking. So let's have a look at what we did tonight. So this is just an example of how we can start the code that can implement the ideas of hill climbing. These types of algorithms can be quite useful when solving these problems. But the real problem with many of these different types of hill climbing variants is that they never make a move that makes our situation worse. They're always going to cells in our current state, look at the neighbors and consider if we can do better than our current state, and move to one of those neighbors. Which of the neighbors we choose may vary based on the algorithms, but we never go from a current position to a position that is worse than our current position. Ultimately, that is what we're going to need to do if we want to be able to find a global maximum or a global minimum, because sometimes if we get stuck, we want to find some way of dislodging ourselves from our local maximum and local minimum in order to find the global maximum or global minimum, or increase the probability that we do find it. Let me look at you, let you have a look at our state space landscape here. So this is an example here. And as you can see, this is our initial state. This line right here, I put a little line right here to indicate that's our initial state. Let's follow it up. I don't know if you're gonna be able to get the whole thing. Let me lower this for you guys so you can get the whole picture. So you can see this is our local, this is our initial state here. Let me fix that. Now as you can see, let me fix this back. Of course, everything's going haywire. So as you can see, this is our initial starting spot. And if we want to go get to our global maximum, which is way up here, let me show you, which is way up here, we won't be able to get to it because our local maximum will be this spot right here. So if we were using this regular hill climbing, it would pick this one as our best option, even though this is our best option here. So it wouldn't be able to break out of this loop here because this is our best position right here. Even though this is the best position overall, we won't be able to get to it because we're stuck here or we lodged here between these two locations. And even if we wanted to get to our lowest point, we couldn't get to it again because this lowest point right here is right next to us. So with the hill climbing function, it's going to try to find the most immediate options next to us instead of looking at the whole global picture. So yeah, that's just what we went over tonight, breaking that down and going over that. And we did take a lot of notes, and we did go over a lot. But yeah, things are moving along. We're gonna keep moving forward. It's a Python Poppy. You guys stay Gucci.